All right, hi everyone. This is the second last talk of today, so I'm going to keep it relatively light, also because I'm quite jet lagged by this point. I'm not going to go into the super nitty gritty of Croissant. Luis, I saw you just emailed me something pretty cool. I wanted to show that off, but I don't think I'll have time, or I don't think it will really fit in with what I'm going for here. Truthfully, Croissant has been going on for a long time, and I think some of you, especially the ML Commons people here, will already know a decent amount about it. But for those of you who don't, this presentation is just to kind of show you guys what we're doing and what's going to happen next. We're splitting it in two. So I'm Neil. I'm a researcher at the Open Data Institute. I'll be leading the first half, which is kind of just about Croissant. And then Rajat later on will talk about something. When I did these slides, I don't know what it is now, but I think it's mostly about applications of Croissant. All right, let's get started. I wanted to build this presentation around a narrative. What data set did any of you use to learn data science when you were doing it? I mean, you can shout out some examples, like there's Iris. I think a lot of people use the MNIST numbers data sets. That's probably the big one, that's especially for machine learning. I was an economics student. Economics students love statistics. I kind of had to know what I was doing, and also an economics student likes the Boston housing data set. I used a YouTube video from Free Code Camp. I think this was 2019. I'm showing my age there. And it taught me pandas, and I think scikit-learn as well, with this data set that kind of allowed you to do these correlation analyses or these regressions, these classification problems regarding different properties about neighborhoods in Boston and their their simultaneity with house prices. Now, the Boston housing data set might have already set up a few flares in the audience's head. Don't know, again, you might have heard of it, you might not have. If you haven't heard of it, the tutorial had me do housing.description, which is because it's a scikit-learn data set, you can just do housing.description and see the metadata. If you look over here, what the hell was I doing? I was using a really bad parameter to understand house prices in Boston. I was using something really outdated, really morally unethical. I mean, we're in California, we're near Silicon Valley. It might not be ethically problematic to some of you or to other people in the audience, but at least for me, it could also represent a legal culpability, right? It could represent a real problem. And this is the sort of question that you have to face as a data scientist, as a machine learning engineer, as an AI practitioner, as anybody doing anything with data these days, which is that metadata matters. You need to know what you're working with. That was quite a bleak example. There's all these sorts of things about duplicates, sparseness, licenses, just the overall structure of the data set, the columns that you're working with, the file formats even. Who collected this data? Who modified it? What modalities am I dealing with? I guess that works for data science, for a data scientist, for an AI practitioner, for an ML person. It also has to work for, it also has to work for agentic AI these days. If you've got an agent, if you've got somebody doing something, well, a model doing something, and it's working with data sets in your enterprise, in your business, in your research, in your academic environment, you need to know what that data set is, and the agentic AI also needs to know what that data set is. If it doesn't, it's running blind. If I go back a slide, ML dataset documentation already exists. This is a known problem, and there's a variety of forms for ML datasets to be understood and well documented before they're used. But I'll be honest, I don't use them as much as I should. Data cards obviously exist and they're very useful, but I think there's a reference that I use which shows how heterogeneous they are on Hugging Face, at least how sparse some of them are. I think I used there was a data set that released recently, and I remember I just looked at data card and it was completely empty. It was an AI Security Institute data set or something like that. It felt benign to me how little people cared about this sort of stuff. And there's also nutrition labels. There's a whole host of ontologies and semantic vocabularies and metadata sort of standards. But if they're sparse, if they're not standardized, if there's a lack of machine readability, that hurts. And especially, as I said, with agentic AI, machine readability is super important. I'm going to put this slide up again. It's a good way to kind of connect metadata, which is, I'll be honest, not the most exciting topic to talk about, to the real world, to the cutting edge of AI. If I talk to business clients, if I talk to people in enterprise, we're sealing a contract for something at the Open Data Institute. and they want to talk about data standards and stuff like that. And we have to talk about metadata to them. They're sitting at the cutting edge. They're looking at data fabrics. They're looking at meshes. I think they're called meshes, something like that, which are like combinations of knowledge graphs and the structured data sets that they use on a day-to-day basis. They don't have metadata standards in place. And we're saying to them, you need to have it, and you need to have it in a machine-readable way. Otherwise, you're not going to be able to do what you say you want to do. To this end, ML Commons has worked tirelessly, and especially the Croissant Working Group has worked tirelessly to kind of build Croissant, which is a building block of better ML data infrastructure, which aims to sort of make it easier to publish, discover, and use datasets and reuse datasets across ML platforms responsibly. The Croissant effort, well, Croissant officially as like a data standard, or as a metadata standard, sorry, officially launched in March 2024. Croissant 1.1, that was a 1.0 specification, there's a 1.1 coming soon. Croissant RAI extension, there's GeoCroissant, there's a bio initiative going on, there's lots of different subjects, like topics that are kind of going on to kind of bring Croissant to a variety of different ways that you talk about data. And intrinsically, Croissant has been linked to data repositories. It's been linked to Hugging Face, to Kaggle, to OpenML, to Dataverse. It's reaching 700,000 data sets. These data sets are automatically provided at least a low-level, like Croissant record for a machine learning practitioner to kind of bring the data set into their environment and have the ML, have the metadata with that data set. That's something that I find really important to tell people. If I went back to that Boston housing data set example, if I couldn't easily access that metadata, then the whole thing is shot, right? I'm still using that weird parameter that I should not be using. And there's a bunch of other parameters in there that I probably shouldn't have been using either. Croissant filtering, Google Dataset Search. Google Dataset Search is an increasingly infrastructural component of ML data discoverability and findability. There's tools, there's an ML Croissant Python library, there's a Croissant editor on the Hugging Face space. There's Eclair, which I don't agree with the name of, I'm just gonna point that out. It's an MCP sort of protocol to kind of access different datasets and search for datasets through Croissant metadata. I would have called it the bakery or the boulangerie, but it got called Eclair. Still not sure about. The ML frameworks that work with Croissant, so that you can, with a Croissant record, bring the entire data set into your environment in a way that suits you, with TensorFlow, with PyTorch, with JAX, with Grain. I'm not sure what the colors look like on this. The Croissant itself, I think it's called Croissant. It's still ambiguous. I think it's called Croissant because of the layers it has. There's the metadata layer, which is the general information and some like ML specific attributes. There's resources, which are the sort of how the files are kind of organized. The structure of the resources, the basic data manipulation, and the semantics. So some ML-specific data interpretations for interoperability. I think when we talk about GeoCroissant especially, that's where that layer comes super important. All of these sorts of metadata tags are in a JSON LD, which is pretty useful for machine learning, at least. And how do you do that? You kind of make it you can just upload your data set to Kaggle or to Hugging Face, and you get it yourself. I think Kaggle have paused it, to be honest, but I'm not sure. There's the Croissant editor on Hugging Face as well, which we kind of implore people to use. I think, I'm not sure what it was for NeurIPS datasets and benchmarks this year, but last year especially, this editor as a Hugging Face space was super important. There's a Python library so that people can just programmatically or like work it into their script to generate Croissant records for their data. We're still talking about LLM-based generation, the pros and cons and the trust aspects of that. And there's a whole organogram of some sort there. And then using Croissant, I mentioned Google Dataset Search, I mentioned Kaggle, Dataverse, OpenML, Hugging Face. With a sort of Pythonic workflow, you can import a Croissant and import the data with it. So importing the metadata and importing the data with it rather than importing data and the metadata with it. It's semantics. But the point is, you get both the data and the metadata. I'm going to keep stressing that. You get the data and you get the metadata together. And you get access to the documentation you need in a machine-readable JSON LD. And that machine readability, again, is super important. More accessible metadata, machine-readable metadata, easy to read, easy to understand metadata, needs more responsible innovation, which is kind of something that we preach a lot, and I think is very at the core of what ML Commons stands for. As I mentioned, Croissant 1.1 is coming soon. I got carried away with the amount of emojis on this slide. I don't exactly know the timelines. I don't know too much about 1.1 myself, but I would say there's a pull request on the GitHub repository that you guys can look at if you want to see a sneak peek. I'm gonna leave it here. It's leaving it here from me, and then Rajat will present his slides, and then we'll do a Q&A together. But you're more than welcome to join us as part of the working group with the link over there, and I'm sure you'll get the slides themselves, or get in touch with the working group email address, or get in touch with me. I will give you guys my email happily, or my LinkedIn or something like that. And I think we can work together towards making the 1.1 implementation after it's kind of released go smoothly, and also like go a lot further than we've already done with those 700,000 data sets. I think there's definitely space to keep momentum behind this initiative going, and definitely part of that is use cases, which is where I think Rajat fits in, or not there. Okay, thank you, everyone.
I think we can do it as of now as well, if there are any questions for the person. Okay, Neil, go ahead with the questions now.
I think Croissant is by nature heavy. I think like the Croissant files, Croissant records that we have and that we work with and we exemplify is a heavy set of fields, and it's a very rich source of metadata. And I think that's sort of the point. Yeah, I guess I can't really answer that by saying we'll address it, because the point is to keep this information flowing and keep people like understanding the full context of the data that they work with. It's definitely something we should pick up, because it limits usability, and I think there's always that conflict between responsibility and usability. I think responsibility always wins out, but it's definitely on the topic and it's on the minds of people in the working group. So I guess watch the space. Luis? Yeah, that's true.
There's a bunch of these examples, also what Rajat has been doing, and then there's other formats that weren't supported out of the box, and then people just basically wrote a wrapper or like an extension, and then it can go into the spec. So yeah, I think it's quite flexible actually for. Yeah, it's open for anyone to support, and I mean there's the spec itself, right? The vocabulary, the fields, but then on the record level, there is all kinds of formats that I don't know. Some people had bundles of CSVs and other, I don't know, tar-gc, and you know there's a whole wild jungle of formats. So there's flexibility to support that.
Yeah, it is well. I get told off about saying it's an open standard if it's not open standard by definition, but it is super open and super out there. There's a GitHub repo which can just be PR'd, and we all work together on those PRs to bring Croissant to what it's needed for. I will leave it at that, and maybe we'll do some questions afterwards as well. Thank you.
Great. Thank you very much. Let's give a round of applause for Neil as well. And Yeah, so now we are moving towards GeoCroissant, which is an extension of Croissant. Since morning, we have been discussing a few things, and I come from a Geo AI background, Geospatial Artificial Intelligence background, and my name is Rajat Shinde. I work with NASA's Office of Data Science and Informatics at University of Alabama in Huntsville. I've been involved with ML Commons with different initiative and work stream, but our major objective has been that how we can translate all of these efforts into domain-specific validation, because we have background and experience in both the fields in development of AI ML practices as well as geospatial domain. So we try to do that, and that is where GeoCroissant came into the proposal. So a brief intro about me, I'll skip it fastly. I work as a data science lead for the ESA-NASA multi-mission algorithm and analysis platform. It's a project which works in collaboration with 2 agencies. And I'm also a member of the NASA AI for Science project community, which is focusing these days on research to operations for foundation models. These are foundation models in geospatial and other domains. With respect to ML Commons, I've been involved in Croissant working group, and then we proposed and started working on GeoCroissant effort, which is getting in a good shape as of now, and also with the AIRR working group in multiple work streams. So I also hold a position with GRSS, which is Geosciences and Remote Sensing Society. It works very closely with IEEE and develops IEEE standards on geospatial domain. So all these things will come into a single circle when I'll be talking more towards adoption side of the GeoCroissant. So this image, Neil has already talked about it, how Croissant ecosystem is tightly integrated with the important factors of AI ML ecosystem, be it the software frameworks, be it the data processing pipelines, or be it the data production platforms. But when we were looking into it and when we were part of it, we found out that the domains or specific domains which work, they do not have direct requirement coming from the metadata as has been defined in the core standard. So for example, the responsible AI attributes, those could be different as compared to the AI ML attributes which are required. And similar to the health domain or the geospatial domain, or recently as we got to interact with some people from material science domain. So all of their attributes are different, which are described, and some of these attributes are pretty relevant when it goes to AI ML workflows. So these modular extensions can be defined on top of the core Croissant ecosystem and can be used, and that is what I will be talking about today. This is an end-to-end use case of an ecosystem which is happening in terms of geospatial processing. Geospatial data is huge in volume. I'll be talking about that a bit. But most of the analysis is done in the cloud, and the entire infrastructure looks like the workflows which are there for cloud-native geospatial data, and then cloud-native computing infrastructure, as well as the cloud-native AI workflows, which connects these data and infrastructure. And there is a scope for standardization in all of these workflows, entire workflows, which works as bridges for doing this in a standardized and interoperable fashion. Now let's talk about the geospatial data. So this is the operating and future science fleet, which is being planned for the entire, for observing data set of Earth observation and Earth-related things. These are all the satellites which is going across solar system. This is the amount of data which we are expecting only for Earth. So all these missions which are being planned to acquire data set across Earth. Another example, which is a recently upcoming mission, which is NISA, the NASA ISRO Synthetic Aperture Radar mission. So we can have a look at it. It is expected that on a single day, this satellite mission will be collecting 140 petabytes of data. And across a 3-year system, it is expected to reach out to 85 terabytes. And one single example of, I mean, we do not need to discuss, we know how much 1 petabyte of data is. But why it is important to discuss this? It is important because this much amount of data will be there, and it will be used to train models. It will be used to generate insights which will be useful in real time. And if we are not putting in proper workflows for processing these datasets, then there is a big challenge. We are not only talking about organizations, but from a user perspective, it's very difficult to process this much amount of data, make a copy of it, and then use it. So the Earth observation datasets is complex. It's related to data quality issues. There is a lot of heterogeneity, and I can showcase those. So this is the different examples of Earth observation datasets which are there. There are images, there are multiple wavelengths, there are sensors which are nearby. There are side camera images, which all the autonomous vehicles, as I was discussing it today, are being captured in real time. And all of these datasets have one thing in common, which is the geospatial relevance. And geospatial relevance is common across majority of the tasks which we are talking. For example, going back to Laura's talk, the previous one, there also the geographical relevance is there with respect to culture, how it evolves in a very close proximity of geography. And as I mentioned, these datasets will be used for developing models, frontier models, foundation models, and then used in real time. So we need to be careful of how these data processing workflows are being defined. Now coming to the Croissant part. So Croissant is based on schema.org, if we are not aware of it. And it uses schema.org properties to define and map its properties to the metadata attributes which come from each specific domain. So some of these are already there in schema.org, but some of these which are not there are defined using the GeoCroissant extension. And these which are not defined are spatial reference information, which is very specific to satellite images. Nested data attributes. So this is going to be coming in the version 1.1, which is going to release soon. This is, for example, of hierarchical dataset representation and how those can be represented. Then in geospatial data formats, there are a lot of metadata standards which are already there. So how we can have an interoperable development with GeoCroissant and introducing the geographical biases, region restricted data access, all of these things which are there, which are targeted by GeoCroissant. So when we started the development, we had a chat with community. There is a big community working, and I'm presenting on their behalf the entire GeoCroissant working group and Croissant working group. So one of the major area was to look into findability and accessibility and search and discovery, which are two important parts for working with these big data sets. There was one interest coming out of a student who worked on space weather datasets. So space weather datasets are close to geospatial datasets, but a bit different in terms of the platform which is being used for acquisition. Then time series analysis, GeoAI applications, and then interoperability with other formats. There are other use cases as well. I'm focusing on these ones which are actively being developed. So this is one example of how dataset will look like if we want to do a GeoCroissant representation. So we can have a look. This is on a file level. If all these files which are there, the satellite images, those are stored as TIFF format. And then there are associated annotations, which is an entire end-to-end mask. And I'll quickly show it towards the end. So this entire JSON file is all what you need to work on for this dataset. You can take this, add into your PyTorch workflow or TensorFlow workflow, run the end-to-end system, develop a model, and use it for inferencing. You don't need to have this entire 512 cross 512 images, which are huge in nature. So yeah, building on the entire ecosystem, we are finalizing the specification as of now. The tools is also almost there. We are compatible with MLCroissant Python library, so you can install only the geospatial attributes if you want using this extension, and then pass it on to your workflows. The notebook, I wanted to show it, but it kind of looks very fast, and I understand with the cognitive level we have right now, it's a bit difficult. So, but I can forward the links later on to follow. This gives an end-to-end workflow for using a GeoCroissant file representation and running it entirely. And I think I'll quickly talk about the potential adopters. So we did a lot of interviews with people who are working in geospatial domain, and these are some of the people who are quite interested in. There are some organizations which have said that they will use it based on community interaction, but the major ones are like GeoAI Africa. That is a really good initiative. I would like to highlight that because there are students and people who are working on all entire Africa AI related datasets, and those will be adopted as a GeoCroissant format if everything goes well. Then CEDA is a platform which hosts entire UK environmental datasets. And so one important thing is like OGC, which is kind of organization for having all the geospatial related standards. They have also supported it to become a community standard. That is still ongoing process, but we'll get to know about it soon. So yeah, if you're interested, or one highlight point which I wanted to highlight from here is, so even though Croissant is there, I understand that we all come from different domains in our specialization. But with this initiative, we got to understand a lot of things, which is how we can quickly translate the core Croissant specification to each of our field and then develop our own extension. Ultimately, the plan is to connect all of these extensions so that data across AI is independent of the domain. It's domain agnostic. So if you're interested, please reach out to the email address or me. Anything works. This is the link to specification. It's about to be launched soon, and link to join Croissant working group as well. Yep, thank you for your attention. Oh, since I have 6 minutes left, I quickly would put Luis on the spot to talk about it, please. So this is a demo which Luis worked on, and we'd like to show it.
This is a good segue to Laura's pitch. So as you guys know, I mean, there's this amazing work that Neil and Co are doing, and then Rajat. So there's all these different application domains. And one of the things that we've been trying to do as well is to basically expand the concept of Croissant, which is all data so far, to be able to wrap all kinds of workflows, which at the moment working title is Croissant Task. And what we did here, this is like bleeding edge, basically, with just an IP address, not even a URL, is to basically leverage the stuff that Laura, Joaquin, and Meg have initiated this year at NeurIPS DB track, which is mandating that every submission with a data set provide a Croissant data plus a code repository if it exists. And we parsed through all these results and are now able to present it in such a way where we can filter through these different tasks, link the paper, link the input data, link to the code repository, download a Croissant task file similar to what you've just seen for the GeoCroissant. So the idea really is to make it more and more convenient for people to work with this kind of stuff, because if you look into the kind of JSON LD hell, it can be intimidating and it's not always nice. So there is a lot of support in the community to build convenience and products around it so that it's actually useful. And I think that's ultimately also one of the bigger lifts. And one of the things we want to push so that NeurIPS can benefit from this and all kinds of communities can benefit from it.
Not just NeurIPS. We really would like to propose this model to ICML, iClear, KDD, all the other machine learning conferences that have data tracks or don't have data tracks yet, but they could follow the same model. I think next to this, so maybe you can come to the opening session. I will and to the town hall. I'll be talking about the use of Croissant and the utility. But one of the main thing is for conferences like NeurIPS, where you have 24,000 submissions, not all of them are data sets, but we had enough, more than 2,000 submissions with various, 84% of our submissions had data set submissions. So the best, really the highest utility of something like this is to allow reviewers to be able to quickly understand what does this data set contain, and how does it compare to the data sets in the same reviewers kind of flow. And the second thing that relates to what Rajat was presenting is the responsible AI properties are really very important. Neil and Rajat, sorry, are very important because currently there is this checklist that actually has all of those things, but in a PDF format, completely machine unprocessable, not structured data. So our challenge and desire is to get everything from the checklist into that Croissant should provide it. We already have this integrated in OpenReview, so the submission, the Croissant fields are actually visible in OpenReview. So it will be great if we can have sort of this utility of what Luis is saying, and also the responsible AI properties as the next version of Croissant for next year. But this means for next year means it should be working pretty soon. Should be something, some minimal set of this should be working definitely before February next year. Sorry, no pressure.
Thanks, Luis. Thanks, Laura. Neil, please. Great. If there are no more questions, thank you very much.